Thank you. Thank you. Thank you. good morning position, so we'll morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to another Godot tutorial video. In this video, I'm going to be making a random level generator in Godot, and it's going to be something like this. Okay, so I'm going to be using a simple walker, or digger as some people call them, to generate tiles in Godot here, or generate a level like this. So this is what we're going to be doing. You can see I'm getting some tile flickering here. I wasn't getting that until I started recording. So this is what we're going to do. I want to make this into a series of some sort, but I don't have an exact plan for it, so I don't know how many videos there will be in this series, but I am planning on making some sort of a series, maybe to explore some different ways of doing random level generation. And this is what I consider to be one of the most basic forms of random level generation, so we're going to start with it. So let's create a new project in Godot. So we're going to come into here, select folder, gonna name this Walker level generation, and create folder, create and edit. Okay, this is also going to be open source under the MIT license, so you all can grab it on my GitHub page. I'll link to that in the description, including the resources that you'll need for this. So you're going to need a tile set, and I've set this one up to be 32 by 32. I'm going to grab that here. So I'm grabbing this tile set and I'm copying it into here. You'll want to click on it, and I'm just going to do import, turn off filter, and re-import so it's nice and clean. We don't get any blurriness on the pixels. So let's delete this here real quick, and we're going to create a new scene. This will be our world. I'm going to save this scene. And we'll go into the project settings and just set our window size so it's 1280 by 720. And just set our windows, and we'll go into the project settings and just set our window size so it's 1280 by 720. Close, save. We'll turn on snap, and we'll set our snap to 32 by 30. Because that's the tile set size. 32. We'll turn on snap, and we'll set our snap to 32 by 32. Because that's the tile set size, so that'll get us an idea of how big each tile is going to be inside of this room. Save again. We'll add a new tile map node to our scene. And we'll come over to cell. Make sure you set this to 32 by 32. And we'll tile map node to our scene, and we'll come over to cell. Make sure you set this to 32 by 32, and we'll come into to tile set, new tile set, and we'll add a new tile set to 32 by 32. And we'll come into tile set, new tile set, and we'll add a new tile set. Two by 32, and we'll come into tile set, new tile set, and we'll add a new tile set.
The bunny, oh, I love the bunny.
Break! I was muted. I thought my audio settings came over with the scenes. They do not. Now I know. Big shish kebab. Alright. Thank you. Alright, so next obstacle. Figuring out how the heck I imported these last time. Like, how the heck did I get this tile set in here? Oh, man. I'll make a new folder. Tiny Dunge. Okay, now where did that folder go? Oh, there it is. Okay. I'm just blind. Classic. Alright. But I can't just... There it is. Okay. So they must have been going somewhere. They're probably here multiple times, and I don't know where they are now. Alright. 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 You just gotta be smarter than the... smarter than the program, I guess. Modify to automatically create tiles. Yes? Hey, like, I need this row too. Oh, and these aren't split right. I bet you mine are... 8, and he's doing it in 32. Okay. So I'm gonna make my project an 8. Configure snap. 8. 8. Okay. I think I need to re-import this now. No? Now they're cut up in... Did it just do it wrong the first time? No. Okay, let's try 16. Let's try 16. There we go. Alright, we're in 16. I am so smart, let me tell you. Let me tell you. Game development, easy. Easy. Easiest thing I've ever done in my life. Alright. Back to the video.
Select our random level generation tile set. Do new auto tile. And select.
Alright, so we already did this.
Select this region here. And we'll come into our snap options. They look good. Selected tile. We'll want to set our bit mask, auto tile bit mask to 3x3 minimal.
Auto tile bit mask. Oh no. Where's that? Selected scene. I don't even see bit mask. Tile set, editor context. Oh no. Hold on, back up. Where are we?
To our snap options, they look good. Selected. And we'll come into our snap options. They look good. Selected tile.
Okay, hold on. He might be... No? Okay. Hey, thanks for the follow. I appreciate it.
I want to set our bit mask, auto tile bit mask to 3x3 minimal.
3x3 minimal. Okay, what is it by? Okay, so it's probably called something different around here. Because his looks just a little different. Subtle size. Auto tile bit mask. I might need to Google where that is. Where is my auto tile bit mask? In Cadet 4. Mask. Best concept auto tile. No, I just need to know where is it. Offset, normal math, name. Editor. Hold on, let me back up the video. See if we can. Okay, so he hit
set new auto tile.
He's like an edit of this. I don't have a. Alright, hold on.
And select, turn on snap, select this region here.
Edit region. Am I dumb? Am I missing something? Okay, hold on. Ad's about to go. Sheesh. What is he in?
And we'll come into our snap options. They look good. Selected tile. We'll want
So he's in an inspector of the. No. Try 3 dots next to the eraser icon towards the bottom of the screen. Here? Remove tiles and fully transparent textures. I mean, that sounds like a good idea, but I don't have any fully transparent textures. Create tiles in non-transparent texture regions. So we've already done that. Down here? Manage tiles. That's not what we want. Open Atlas merger tool. I don't think that's what we want. Well, maybe it's just something they've just worked in now. I'm going to make the dangerous call of let's just skip this step and
to set our bit and we
see
can
what
come
happens.
to our icon. We'll select this tile for our icon. Bit mask. Now you've seen me do this before in other videos, so I'm not going to
Bit
describe
mask.
in great detail how to set this up.
I have not seen you do this before in other videos. Oh no. Oh no. Okay, alright, there's something we're missing. How do we do this?
And we'll turn
All
off
right.
set, tile set, and
Okay, so right here we look the same, except for. Okay, so he's in the tile set right here under the this thing's right here says tile set under the video. We're in tile set. Patterns? Is it under patterns? No. Okay.
add a new tile set.
Okay, we did that.
Select our random level generation tile set.
Uh-huh.
Do new auto.
New auto tile. Okay, so ours is oh no. Excuse me. Ours is tiled.
And select, turn on snap, select this region here.
It just looks so different.
And we'll come into our snap options.
So Are you supposed to be on the tile map set or tile map? He is in tile set. I am also in tile set. It's possible it got moved to tile map, but I don't think so. Animation, audio, debugger, output, no. Tiles, I'm supposed to be in tile set.
They look good. Selected tile. We'll want to set our bit mask, auto tile bit mask to 3x3 minimal. And we can come to our icon. We'll select this tile for our icon. Bit mask. Now, you've seen me do this before in other videos, so I'm not going to describe in great detail how to set this up. I'll probably actually fast forward this, but at the end of it, you can just pause the video and copy to make sure yours looks like mine if you haven't done this before. If you have watched my videos on how to set up a bit mask like, or if you haven't watched my videos on how to set up a bit mask like this and the kind of pattern that is associated with it, I will have a video linked at the top of this video as well that you can click on.
Alright, I guess we're going to this video.
Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to the Godot Action RPG series. This is Sprite 2D. Just drag this all the way up to the top. And its texture will be inside of world and grass background.png. For the offset, let's uncheck centered. And you can see there is our sprite. However, if we drag this out, it's going to stretch it, right? And that's not what we want.
No, we don't want that.
So how do we make this sprite fill up the entire area right here without stretching it like that? Well, if we come into region here, we can enable region. And the first thing you'll notice is that it shrinks all the way down like this. And we also get a new tab down here called texture region. And we can come into here, click on this, and we can see.
Okay, but we're in a tile map, not a sprite.
Anyways, that just, you could stick your sprite in the middle of your room by setting its offset, by stretching our region and heat flag right here. And so that's essentially what you're doing. If we want this to repeat across a long distance, your width and height in your region to be 320 by 1 easily inside of our room. Now, which one's better? I don't actually really know because I don't know how big of a drawback it is to use a control node. Obviously, the control node is more convenient, right? It's a lot more convenient to use a texture rect like this, but maybe there's drawbacks that I haven't run
Thanks,
into
Ryan. I'll
with
see you
using a
around.
control node like this.
Appreciate you.
So I don't know which one's better. I think for this series, I'm going to be using the first method. So we'll get rid of our control node and just make our background visible, and then manually set our rect properties over here if we need this to be bigger. And the reason I want to do that is just to kind of be safe, because I don't know if I'll run into issues with the control node, but I should be fine just using a sprite like this. So that's the plan. If you guys have any comments on this in the description, just let me know. Okay, so this already makes our game look a lot better because now we've got a nice background to go along with our character. Let's add one more little bit here. We're going to learn about tiles.
Okay.
So let's create a new node, attach it to our world, and this will be a tile map node.
Okay, okay.
We'll drag this up. I want this to be below our background so that it draws on top of it, but above our Y sort stuff. So then we can click on our tile map, and we can create a new tile map. But we're gonna want to set our cell size. So let's set this to 16 by 16. That will be the cell size, and we'll come to the tile set property here.
Okay.
We'll do new
so I
tile
think
set.
excuse me. I think our biggest issue here is he's working in Godot 3. And we're using 4. Maybe let's try. See if we can find it in the 4. Okay.
Hello fellow Godot enjoyers.
Oh.
In developing my latest game, I ventured into dungeon generation using Godot 4. Surprisingly, I couldn't find any existing tutorials on this topic for Godot 4.
Yeah, I'm
Those of you
working
familiar
with
with Godot 3X will notice that adapting to the new functions in Godot 4 can be quite challenging. I experienced some difficulty in modifying Heartbeast's tutorial code to work with the changes in Godot 4, which inspired me to create this tutorial. My aim is to simplify the process for others
Thank
who
you.
are also interested in level generation.
Mm-hmm.
In this tutorial, I'll demonstrate how I adapted and optimized the Heartbeast tutorial script for Godot 4.x. I will focus on the functions that have undergone significant changes in Godot 4x, such as getCell source ID, tilemap.setCellsChanterrainConnect, and setCell. I'll explore how these functions are now applied in level generation, which is a crucial aspect of our dungeon creation process. It's noteworthy to understand how these functions differ from their counterparts in Godot 3x. To grasp these changes, I delved deeply into a variety of somewhat related tutorials, scoured the Godot documentation, and sifted through numerous forum posts. This journey helped me piece together the workings of Godot 4x for effective level generation. Firstly, setting up the wall layer with a fully enclosed 1x1 tile is crucial, and the reason behind this will become clear later in the video when I delve into the algorithm's mechanics. We use a dual layer strategy in our design, distinctly separating the floor from the walls. This approach is both clever and practical, ensuring that generated objects are placed correctly. Our object spawner functions responsible for placing treasuries, enemies, the player, and the level exit are programmed to only interact with the floor tiles. This design choice effectively prevents objects from spawning inside walls, as the ground layer tiles are free of any wall elements. This dual layer method is particularly advantageous over a single layer setup, where integrated wells in the ground layer can lead to objects erroneously spawning inside collision shapes. In my approach, each step taken by the walker not only navigates through the level but also carves out walls, which we initially set up manually as blocks to be carved. This process is evident when you observe the function calling the setCell function twice, targeting each layer separately. For enhanced code readability, I've assigned the layer indices to variables. The ground layer is integer 0, and the wall layer is integer 1. In my setup, the floor tile is represented by vector2i 9,2. I chose this tile for the entire floor layer as my prototype tile set still included walls and lacked variety in floor tiles. However, you can certainly opt for your own floor tiles, perhaps with distinct paths. Had my tile set not included walls, I would have selected the fully walled single ground tile, which in a standard tile map pattern from the internet would correspond to vector2i low, 3. To make this system work, as I mentioned earlier, it's vital to initially fill your generation area with wall tiles on the wall layer. By using the setCell function, we can precisely control the layout, ensuring that the terrain connects seamlessly. In the generateLevel function, we construct a map using a walker method, similar to the one in Heartbeast's tutorial. However, I've optimized this method further. Now, it includes an improved line of code specifically designed to prevent backtracking. This enhancement also involves erasing its previous direction. effectively eliminating any repetitive circling. That's right, no more running in circles. The connect atlas tiles function in my code plays a pivotal role in bringing the generated level to life. In Godot 4x, this function replaces the old update bit mascot region function from Godot 3x with set cells terrain connect. This updated function enables us to implement auto-tiling through code, just as we did previously. It's applied to all the wall and floor tiles we generated earlier.
3% of
Interestingly, the function also applies to excess wall tiles, which, as I discovered, is not a problem. In fact, it helps enclose the void around the level without causing any performance issues. A concern I initially had, this function is where the magic truly happens. It iterates through all the layers, connecting them with auto-tiling, breathing life into our level.
Okay.
However, it's crucial to note that this auto-tiling only works effectively with fully walled tiles. Using different tiles can lead to unexpected and often undesirable results. When you generate a level using this method it should resemble the example I'm showing here. Please overlook the placeholder graphics, as I'm still in the prototyping phase of this game. My goal is to have a presentable prototype ready, possibly with a demo on itch.io by early 2024. Now if you find that the levels generated seem too open or spacious, there's an easy fix. You can tweak the tile map of the wall layer to better suit your preferences. In my case, I started with a wall layer tile template featuring thin walls. However, opting for a template with thicker walls can give the level a less spacious, more compact appearance. I recently attempted to further optimize our maze generation process and encountered a challenge when trying to fence the maze. The goal was to eliminate the need for pre-placing tiles on the wall layers. The idea behind this algorithm was to make it aware of the current tile's surroundings and to automatically place wall tiles on its empty neighboring spaces. Initially, I thought this optimization was necessary because I noticed a few milliseconds of lag during level generation, but this turned out to be a sporadic bug with my main PC. Surprisingly, when I tested the generation on an old Lenovo Potato laptop, a T460 running Ubuntu, it worked flawlessly without any lag. This experience really underscored the lightweight efficiency of the engine, and I'm excited for fellow Potato PC enjoyers to try my game upon completion.
Yeah, Potato
However,
PCs.
I'm still facing an issue. The tile connections are being less than cooperative. If anyone out there has suggestions on how to smooth out these wrinkles, I'm all ears. Your insights could be invaluable in making this process more efficient. This is what it looked like when I tried to fence the maze. The placement was very inconsistent. There you have it. With these functions and a dash of creativity, you're now equipped to generate intricate dungeon levels in Godot 4. Remember, experimentation and adaptation are key to making the code align with your unique vision. I'd love to hear about your experiences and any variations you come up with. Since this is my first game development tutorial, your feedback would be greatly appreciated. I was inspired to create this tutorial because I believe it could be a valuable resource for many. And that concludes today's tutorial. If you found it helpful, don't hesitate to hit that like button and subscribe for more tips and tricks. Feel free to drop any questions or suggestions in the comments.
Oh no. Okay. Okay, so one of the comments was saying it was from this guy's video, the code from this guy's video, and the code in this video. Oh no. This might be a multi-day process. Okay. Between the functions and tutorials is pretty nice for Godot. Pretty nice, but some things need to be changed. That's why I have my code a bit. Okay. What are the Caroline wall? I really can't understand down here. Seeing the generate level function after the for location in map part. So a tutorial like this, nice. Alright, so once we understand this, we're going to make a video on how the heck this works in Godot 4 in more detail. Alright, so I guess, so he's saying we need to like fill this all in, right?
Changes in Godot 4x, such as get cell source ID, tile map
cell
set
source
cell
ID.
terrain connect, and set cell. I'll explore how these functions are now applied in level generation, which is a crucial aspect of our dungeon creation process. It's noteworthy to understand how these functions differ from their counterparts in Godot 3x. To grasp these changes, I delved deeply into a variety of somewhat related tutorials, scoured the Godot documentation, and sifted through numerous forum posts. This journey helped me piece together the workings of Godot 4x for effective level generation. Firstly, setting up the wall layer with a fully enclosed 1x1 tile is crucial, and the reason behind this will become clear later in the video when I delve into the algorithm's mechanics. We use a dual layer strategy in our design, distinctly separating the floor from the walls. This approach is both clever and practical, ensuring that generated objects are placed correctly. Our object spawner functions responsible for placing treasuries, enemies, the player, and the level exit are programmed to only interact with the floor tiles. This design choice effectively prevents objects from the player and the level exit. Objects are placed correctly. Our object spawner functions responsible for placing treasuries, enemies, the player, and the level exit are programmed to only interact with the floor tiles.
Only interact with floor tiles.
This design choice effectively prevents objects from spawning inside walls, as the ground layer tiles are free of any wall elements. This dual layer method is particularly advantageous over a single layer setup, where interguarded walls in the ground layer can lead to objects erroneously spawning inside collision shapes. In my approach, each step taken by the walker not only navigates through the level but also carves out walls, which we initially set up manually as blocks to be carved. This process is evident when you observe the function calling the setCell function twice, targeting each layer separately. For enhanced code readability, I've assigned the layer indices to variables. The ground layer is integers.
Okay, so function generate level walker equals. Hold on, I want to see if he expanded on this at all in another video. He did not. All right. Or location and map. Okay, so we're gonna save that to watch later. Sounds like I need to get through the coding of this, then come maybe even the second one he has, the number 2, maybe even number 3, and then come to this guy's video to make it work in 4. Sheesh. All right, we got a project ahead of us.
So what you can do now is we're going to come up to the top left hand side of our view, and we're going to hold Control and Shift and click and then drag all the way down to the bottom right hand side.
Okay. Control Shift. Control Shift click. Oh no, that did not do what we wanted it to. I didn't want to turn this. What am I doing? All right. There we go. Why did it work this time? Do we want this any bigger? Well, we might want this a little bigger. Let's go to like here. I think. For now. For testing purposes. It'll probably change per level of the actual game. Okay.
And you can see I went just past the edges of the screen and created a big giant black square for our tile set.
Just past the edges. All right. Oh, I'm... Okay.
Now we can save. So now we're going to be creating a new script. We'll come into our scripts here, do new script. We'll call this walker.
New script. Walker.
And we'll do class.
Wait, hold on. Did he do any other shenanigans
Script.
of the...
We'll come into our scripts here, do new script. We'll call this walker.
Nope. Okay.
And we'll do class name walker. That just allows us to use this walker without having to preload it or load it. We can just use this class name to instance it.
Okay. And then he deleted all this stuff. Okay. So class name walker. All right.
And this is going to have a few variables and constants. First of all, let's set up our constants. These are going to be the different directions that we can move in.
Wait. Did he... Hold on. Is this just the code? And I can just watch this back later? What is... this is my first time reading on GitHub. I don't know if I understand this. .gd. Okay, so this is the Walker file he set up. I guess he does... these in a different part. All right, can I just download this whole thing? Pull requests for update. Um, what am I looking at? That just looks like a bunch of mumbo jumbo. some of this in red. I don't know what I'm looking at. Okay, so like this is the exit door. I guess they're doing it in a different part. The player. Oh, is he saying what doesn't work and then fixes it? Is that what's happening here? All right, hold on. Let me pull this up again. Okay, hold on. Have a comparable side by side here. Okay, so yeah, he has an exit door. But then in 4, in 4, it's a lot longer. Okay. Well, what's the worst that could happen? Can I just go like this? Hacker. Okay. Um rooms. What is the red trying to tell me? Stens node. Locker. Is it just like his edits? Like he took that out? I don't know, but I don't need this. Okay. Function. Expected indented block after function. Where was that? Where'd it go? Okay, let's put our music back on here. All right. Get this out of here. Where was it? Oh. Here? Yeah, okay. So, function. Okay, so I'm gonna assume they're saying get rid of this. Will that fix that? Okay. So I guess like the red is get rid of and the green is add. I'm learning. Alright, so the 4-step in. And I need to. So it's like a patch note. Okay. Get rid of this line too. Okay, we're learning. We're learning. Then I need to get rid of this else statement here. Else change direction under the history thing. Okay. Where was I? Okay. What was that trying to say? Place room. Function. Change direction. Place room. Step sense turn 0. Variable directions. Directions erase. Wait, can I just have it, okay. Place room. I don't know why that got squished. Place room. So I'm real special. Let me tell you. Okay. Need these 2 lines. All right. Delete this line. Paste this in here. But I don't need this, like, indentation thing. We're gonna go like this. That looks happy. Okay. Okay, I guess it doesn't like this now. Okay. Okay, get rid of this. Function place room. Position. Vector 2. Okay. Alright. Function create room. Alright. Oh, wait. Why doesn't it like that? I guess I need to get rid of this here, right? All right. Huh. Okay, so I guess this makes the walker work. Can I test it? Okay, it didn't do anything.
And this will be an array, and we'll have vector2 dot right, vector2 dot up, vector2 dot left, and vector2 dot down. So that will just be a list of all the different directions we can go in. Then we're going to set up a position, so var position, and we can just set this to vector2.0 for now. We'll set up a direction. We'll set this to vector2.right, starting off. We'll set up the borders. Now this is important. This helps prevent our walker from going outside of a certain area. So we're going to have the borders here. It's going to be a rect2. We'll have a step history. Step history. This is where we're going to store every single step that our walker takes. And then we'll have steps since turn. So basically we want to keep track. That's just a little bit of polish to keep track of how many steps we've taken since our last turn, so that we don't have super long hallways in our level generation. And so that's not necessary, but it's something you can you can add as well. And I like to do it. I think it looks nicer not to have super long hallways. So we're going to have an init function, and this function is where when we create our new walker, where we can pass in a starting position and a new border. So we'll say the first thing we need to do is make sure that our starting position is inside of our borders. So we'll say assert new border, new borders dot has point starting position. So this will error right here if our starting point isn't inside of our borders. And we'll say position equals starting point, and borders, well, step history dot append position, because we want our very first position to be inside of our step history. So we'll add that to our step history. Then we'll say borders equals new borders. There we go. That's all we need for our init function. Now we're going to set up our walk. Well, we're going to set up our step function next. Well, we'll set up our walk function because we're going to have a walk function that will take an amount of steps that we want to walk. But for now, just do pass. We're going to have a step function. This is for taking a single step. You can just do pass.
Make it so no repeat steps as position. Why doesn't it? I'll keep listening.
And we're going to have a change direction function. So this will be every time we want to change directions. We'll just pass here as well for now. So we'll start with the step function because it's pretty straightforward. We'll just say var target position. This is the position we want to step to, equals position plus direction. So we're going to get a target position, and then we'll try and move towards that target position. If borders.has point target position steps since turn plus equals 1. So we'll take another, we'll add to our steps since the last time we turned, and we'll move in that, and then we'll move in that direction. Position equals target position. And then we want to return true. This basically just says, yeah, we were able to take a step. Else, return false. No, we weren't able to take a step because that direction would go outside of our borders. That's what this says. If the target position is inside the borders, take a step. Else, return false because we can't actually go there. It's outside of the borders. Okay? So once we have that set up, we can set up our change direction function. So we'll come down here and we'll say steps since turn equals 0, because if we're changing direction, then we want to reset our steps since the last time we turned, because we're turning now. Var directions, make sure you have an S here, equals directions, capitalized. This is our array. And I don't know if we have to duplicate it. We'll see. We'll do directions. Make sure you have an S again. Dot erase direction. So what does this do? I'm going to add a few returns here so it's not so low on my screen. What does this do? This removes the current direction that we're going from this list of all the possible directions to make sure that we don't ever go in the same direction that we were just going in. That wouldn't make sense, right? So it removes it from that list. So then we'll say directions dot shuffle. So now we're shuffling the list because we're going to pick a new direction. And then we'll say while not borders dot has point position plus direction. Oh, we got to do this first though. We got to say direction without the S this time, because this isn't our list of directions. Direction equals directions. Directions with the S dot pop front. So what does that do? That grabs the very first direction from our list of directions. So you could imagine that if this list was shuffled, it might be the up direction. Okay, and then it sets our direction equal to that. But when you say pop front, the pop part also removes it from this list. So this list will get smaller each time we pop a direction from it. And that allows us to make sure that we don't check the same direction multiple times when we're checking to see if it's inside the border. So this will then check to see if we can move in that direction. And if we can't, then it will try to grab another direction instead. Direction equals directions dot pop front. So if we're unable to move in this direction, it will just pick another direction right after. And that's it. Now we can set up our walk. So our walk, it will walk for a certain amount of steps, and then it will return the step history, basically a list of arrays that includes all the positions that we walked on. So we can say here, for step in steps. And the first thing we want to do is check to see if we want to change directions. So we'll say if rand f is less than or equal to 0.25, or steps since turn is greater than or equal to 4, change direction. So this gives us about a 25% chance to change directions and a 100% chance to change directions if we've gone for more than 4 steps. That means we'll never have a hallway that's longer than 4 steps. And this seems pretty good, but you can tweak these numbers if you want to try messing with it. If you want to lower these odds or raise this so you can have longer hallways, you can mess with those numbers a little bit. And they could be stored in variables up here too, consts maybe. The next step here inside of our walk function is to actually try and take a step. So we'll say if step. Now remember, this will return true if we're able to take a step, and false if we can't because it's outside of our borders. So we'll say if step history dot append position. So that would say if we're able to take a step, then add our new position. It will actually take that step, and then it will add our new position to our step history.
Okay.
Else, change direction. We need to change directions because we can't actually take a step. It would try and go outside the border. And then finally, we just call at the end of all of this, so make sure you're lined up with the 4 here, we return step history. So this will return our step history back out to whoever needs it, and we can use that. So now we'll come to our world, and we'll create a new script. And inside of our world script, we're just going to have the ready function. Well, first we need to get access to our tile map, actually. I lied. So let's do onReadyVar tile map equals $tile map. So I did this lowercase and this uppercase here. So then we get access to this tile map. And we can create the borders that we want up here too. So var borders equals rect2. So now it's going to take we can pass either 4 floats in to represent the borders or 2 vectors. So let's do the 4 floats, it's easier. So we'll start at position 1 and 1, because we want a 1 tile border at the edge of the room. And then we'll go to position 38 and 21. So why did I pick these numbers? I can show you. Let's save here, we'll come back to 2D, and we'll grab this convenient little tool up here called ruler mode in Godot. And this allows me to click anywhere in here and make measurements with this little ruler. Okay, and it will give me the pixels, and it will also give me the units. Now the units is determined by our snap, which is 32 by 32. So we want our borders to be, we want a 1 tile border all around the view. So we want to go from here down to here. And sure, that's not quite a 1 tile border at the bottom, but I don't mind. It should be fine. So that gives us, you can see 21 units high and 38 units wide. And if you come back into here, you can see I did 38 wide, 21 high. Just like that. So that gives us the border that we need. So if you were going to do a different size for your world, you could use that same ruler to measure and get the border. Or you could try and figure it out programmatically, but for the first video I decided to just use this tool and measure. You'd only really need to figure it out programmatically if you were going to have different sized rooms for your levels, but I'm not going to be doing that. So let's create a new function called generate level, like this. Now in this function, we need to actually create our walker. So let's start by doing that. Var walker equals walker, uppercase this time, so lowercase first, uppercase now.
So where was this a script of? The script of the world? So is this the walker and then the world is calling on the walker? Is that how this is working? Like, we made the thing and now the world is calling on the thing to do what it was made to do? Is that what's happening? Alright, so I'm going to go back to... So, his code was called world. So... Okay, I don't have these yet, so I'm going to mark them out. I don't have a lot of these yet. Okay, what time is it? Okay. Fortunately, I'm running out of time. However, I know what direction we need to go in now. And we're just gonna follow along with this as we go. And we'll get this going. I'm actually gonna leave these undone while we're here. Okay, cool. All right, it's been fun. Thanks for everyone who stopped by, gifted subs or sub themselves, and followed the channel. Appreciate y'all. Y'all have a great rest of your day. Later.